and then with the same reliability as to completely disable itself for the next 25 years, guaranteeing that no matter what you do, it will not turn on again.
Welcome back on the SpaceInfo podcast. Here we talk about space and everything related to it. If you are passionate about space, astronomy, technology and everything about it, you can join all our social platforms at the SpaceInfo Club or our website at www.spaceinfo.club, where tons of content and a community of experts are there waiting for you. This is the SpaceInfo Club. Good morning to everyone. Today we talk with Emilio, who is working at Argotec. Good morning, Emilio. How are you?
Fine, thanks, and good morning, everyone.
So, what do you do at Argotec, and what is Argotec for the people who don't know it?
So, Argotec is an Italian aerospace company, now also active on the US market, and I'm an electronic engineer. I joined Argotec in 2016, and since then I mainly worked in the avionics unit of the company. So we designed small satellites, among other things. So I contributed to the development of the avionics subsystems that we use on our satellites. And now I'm leading the electronics unit, and I'm also working in product management for the company.
Oh, so you do a lot of things at Argotec.
Yeah, especially in the beginning. When I joined, the company was still quite small. We were 20 people in 2016. Now we are more than 160. So wow. when you are a few, you have to do many things. But then, let's say, we became now a middle-sized company. So now I have a lot of wonderful colleagues that I can share the workload with. But especially in the beginning, I had the chance to work on many things, let's say so.
So you mentioned that you are both working on electronics and avionics, and product management. Which is your favorite field?
I'm definitely a product guy. I remember already at the university pushing as much as possible to do product development courses, because I really like, let's say, all the journey of a product, from the customer need up to the delivery of the actual product. And here in Argotec, I was lucky because we are not just a satellite integrator, but we built our own technology in terms of hardware, software, services, subsystem, satellites. So we built many products in the last 7-8 years, and I had the chance to let's say, follow a few of them during their life cycle, up to the flights and very successful missions.
So, okay, before going on, just a brief precision. I would say that the avionics is the systems, that part of the satellite, correct me if I'm wrong, that allows it to be controlled and to have data on board to be processed, and everything that is about satellite, let's say, management, what it can do and how it can be done, is controlled by the avionics. Is it right?
Yeah, absolutely. For example, we develop onboard computers, which are let's say the core of the satellite in terms of, let's say, intelligence, autonomy. So the onboard computer has a lot of sensors, talk with all the subsystems that we have in the satellite in order to understand the status of the spacecraft and to execute the mission in the different operative modes. And let's say it takes care of the spacecraft health, and it takes care of executing mission sequences. Or for example, another important avionics system we work on are the transponders. So basically the radio that we use to communicate between Earth and the satellites. And this is another crucial piece of equipment, because without communication it will be basically impossible to do anything with the satellites. And we developed internally this kind of subsystem, especially for small platforms. So let's say we also have the added difficulty of, let's say, keeping equipment that usually can weigh tens of kilograms and can be quite bulky, and reduce that down to, I don't know, 300 grams, and something that you can you can have in your hand.
So yeah, I think that reducing the weight is one of the biggest challenges in your job. I think because differently from a lot of other companies that use COTS, so components that are commercially available, I would say like that. You do everything, almost everything inside your company. So that's very interesting on this point.
Yeah, and let's see, another important requirement for us was that we tried doing things that were never done before. For example, with LiCeCube, we actually performed an asteroid mission with a CubeSat, something that was, let's say, never attempted. CubeSats usually were used just in low Earth orbit with simple missions, and you can use commercial parts for that, as you were saying. We tried, and we did actually. We started from, on the other end, high-end, let's say, technology used for interplanetary spacecraft that usually, let's say, are hundreds of kilograms or a few tons in mass. And we downsized their size down to CubeSat compatible form factor. So that was one of the big challenges that we faced, but it was crucially important for us because it enabled new frontiers. For example, with LiCeCube, it was about a scientific mission on an asteroid, but for the future, it will be about providing services in remote locations like the Moon, Mars, and having a look at the launch costs for remote locations like the Moon and Mars. We are talking about extremely high numbers, hundreds of thousands of euros per kilogram, for example, around the Moon, which is a completely different economic environment with respect to the Earth. And so, for example, the kind of technology that we developed for LiCeCube is really an enabler with respect to the sustainability of services, for example, in this case, beyond the Earth orbit.
Yeah, so I see that this is one of the most, let's say, differentiating point with respect to the other companies. So, which now I see which is your business line, I would say, but which are the differences between you and the other companies that you see as a strength point?
Yeah, so let's say, continuing on what I was telling before, for sure we started the new product lines that were not existing on the market. So we developed the technology to execute deep space mission, robotic exploration of remote bodies with small satellites. And we did it, let's say, LiCeCube mission launched almost 3 years ago. So, and it enabled something new. LiCeCube also, let's say, won the Mission of the Year award. It was the first small sat ever to operate near an asteroid. It was also the first full Italian interplanetary probe.
Wait a minute, maybe it's the first time you're listening to the SpaceInfo podcast. So I have to let you know that SpaceInfo.club is a platform and a community. We are today counting more than 130,000 followers and members across all the different platforms. So I strongly invite you to visit our website at www.spaceinfo.club to discover all the content we publish, and also our Instagram account and LinkedIn profile. If you're a company or a professional who'd like to be featured on our platform, don't hesitate to contact us, so you'll be featured on our magazine, articles, and also can participate in the SpaceInfo podcast. Now, back to the episode.
And so we have these capabilities regarding technology for small satellite able to operate in very hostile environment, but also able to operate with high autonomy. One other thing that we pushed a lot in the past, and we keep pushing, is the onboard autonomy, the onboard processing, the capability of the satellite to face, let's say, unscripted scenarios, things that cannot be predicted in advance, and to operate accordingly with onboard intelligence. This was crucial for LiCeCube, and this is crucial for a number of other applications. So what I think is that we are in a unique position thanks to the technology, the product that we developed, and the service we are developing now, that can be reused in a wide variety of applications. I talked about the Moon, I talked about Mars, but for example also in Earth orbit, in environment like MEO orbit, geo orbit, defense application, but also, let's say, staying in the low Earth orbit but going into high performance application. not let's say the usual one, I think that we have a tremendous competitive advantage given the amount of capability that we managed to pack in so small platforms. We are talking about satellites, the smallest one go down to 15 kilogram. We are now working at bigger platforms, the 65 kilogram ones, but we are still, let's say, talking about much smaller platform, especially if you compare at equal capacity with other platform with the same capacity of ours.
Yeah, and maybe we could mention some also some constellation application, if it's the case for you. I think, well, if you've been following the SpaceInfo Club for some time, maybe you've seen that we also talked about with the IRDE space program team, and I think that you're involved also in this program, and okay.
We are involved up to the end of my hair in the program. We are working very hard. Of course, as our listeners know, IRIDE is a constellation of constellation built for the Italian government, and it's mainly about Earth observation. So we are one of the companies that are developing part of this system of constellations, and in particular, we are working on an Earth observation constellation with satellites around 65 kilogram, with multispectral sensors. And we are already, let's say, the first satellite is actually already built. You know, we are working on the other ones. We have a first batch of 10 satellites that will be completed within this year, and we are already working on a second batch of 15 satellites. So we are talking about, let's say, we are still continue working and supporting scientific missions, the one like ArgoMoon, LICECube, which are specific application, one-off mission. On the other end, we are starting operating at constellation scale. So we are going to have a throughput of 10 satellites this year, 15 next one, and our new factory, the space park, it will be capable to handle one satellite per week. So we are definitely scaling into the constellation. And our contribution to IRIDE, which is the HAWK for Earth observation constellation, HAWK being the name of our platform, will be the first constellation that will be deploying very, very soon.
Okay, so just to make the point, you mentioned the space park. For people who don't know, it will be your let's say your new headquarter, where the all the Argotec production will happen. And if you're listening now, I think you heard it right. He said one satellite per week. So that's an amazing number. If you think that nowadays a lot of satellites require a lot of time to be produced on the component side, on the building side, and also I think, correct me if I'm wrong, because a lot of satellites are very different from themselves. But when you are able to replicate the same, let's say, model with very little differences between each other, you can product satellites like, let's say, common industrial product. And I think that this is one of the keys of the success for the future space economy. I think. What do you think, Emilio?
Yeah, I think it will be an enabler in many ways. As you were. Let's say saying, of course it will be about increasing the throughput. So this year we are about one satellite per month. We are going to be at one satellite per week, and this is an enabler for constellations, because you don't want to deploy a constellation over 10 years, because at that point, let's say, when the full service will reach the target performance, the first satellites are going to be at the end of life. So it is definitely an enabler to build constellation systems with high performance in a reasonable amount of time. It will be about cost, because it will make satellite more similar to industrial application, industrial product, and less similar to special platforms. Even if, as I was saying, we are still working with ESA, with NASA at scientific missions, because they are very important to advance our technology and stay, let's say, on the top notch of the market. It will also be about timing. one important thing in the industry is about responsive space. It's something that is discussed a lot, both in private commercial markets, but also about defense application with the changing political environment we have. And so having a supply chain, an active supply chain, with the capability also to produce in-house. And at the space park, we are not talking just about assembling satellite. At the space park, we are talking about assembling complex electronic on site. We are talking about producing mechanical parts. We are talking about controlling missions from our mission control center. We are talking about developing digital twins, machine learning models, having the whole chain from, let's say, almost from the raw material till the deployment of the service and the operation of the service help us to answer to the requests that we have of shorter and shorter time from, let's say, the start of the project till the commissioning of the service. And let's say for these reasons, but also, let's say, for the reason that we are growing in number, the space park will be really an enabler, and we are, let's say, very few months away from its official opening and inauguration. So I'm really looking forward to starting operating from our new headquarters.
Yeah, I think that's amazing. Also, exploiting a new variable in the field, which is time to market, is I think one of the most innovative thing. If you use this time to market as a driver for what you're doing, I think that this is actually the future of space economy. Since well, up to some time ago, this was not even a thought variable. You only thought about the scientific research, developing new products, but they were unique and one of a kind. You as you mentioned, you just built one satellite for one application, maybe the space or Earth observation, everything. But then now we are inserting this kind of highly responsive industry, which is the space sector, into an integrated field together with the other technological environment. And I think this is really the future of space. Well, you also mentioned that you're still working with public agencies like ESA and NASA, but also, for example, the IRIDE program is an example of collaboration with the public sector and the private one. I recall to the public that Argotec is a private company. So how do you see, let's say, the differences and also the strong points of working together with both the public and the private sector?
No, just to add a little bit about the responsiveness, I think it always was one of our strengths. Already, for example, for LiceCube, we built and delivered the satellite in something like 18 months. And it was that part of the reason was, one reason was that we had the technology we already developed for Argomoon. And we were, I think, the only one crazy enough to say yes to the NASA request and the Italian Space Agency trust to do, okay, we are doing it and we will do it in 18 months. With IRIDE, again, as you know, the schedule of IRIDE program is impressive. So we actually have the integrated satellite for the first batch. We are working on the following ones. And if you have a look at the timeline of the project, when it started, where it's going, when we are going to deliver, it's impressive. I think it is something unprecedented in Italy, but in the global market. And we are working now at next generation products, which are specifically designed for the beginning to be mass produced in the space park. And this is something that will do a tremendous difference. And I just wanna, let's say thank you to all my colleagues that are working on IRIDE, because they are working through holidays, through weekend, during the day, at night. They are really working around the clock to stay on schedule, which is paramount for our government, and we are really doing our best. Talking about the coexistence between the private and the public, I think that we are having a look at a market which is highlighting the importance of being great at both. Because we are looking at, let's say, a lot of companies which started as completely commercial are struggling now to be profitable, Also, the investors are, let's say, colder than in the past. And there's a big traction from governmental project and defense project, especially in the latest years with the changing global situation. But one part of the system cannot live without the other, because in the past, let's say, space was almost, let's say, completely governmental, completely public. But we know that we did great things, but it had its limitation, that kind of system. You are slow, you spend a lot. So I think that the coexistence between the commercial services and the defense, the governmental, the scientific need can really prove beneficial each other, because of course with the big programs from governments, from agencies, you can have, if you are smart enough and good enough to execute, you can also reinvest a lot in terms of people that you know, capability, facilities, and on the other end, developing for the commercial market under, let's say, the timing constraints. The business plan of a commercial sector can give you an edge to do better also in the other fields. Or you can also develop dual-use technology that it can be beneficial both for your, let's say, for your government, for defense application, but also to do science or to provide the commercial services. And this is something that we are trying to do as much as possible. And I think that it will prove successful in the next year. I'm not seeing, let's say, a market focus only on commercial or only on defense. We are trying to combine the best of both worlds and leverage the strength of each of them to perform better in the other.
Yeah, just to be clear to the people who are listening, you mentioned that there are some services that can be given, for example, from Earth observation constellation or satellites to a general, let's say, general population or private companies or public entities or something like that. I would like just to mention, for example, that thanks to Earth observation, you can give services that are the kind of monitoring of the territory. You can monitor the seas, for example, the coastal lines of, I think, of Italy, for example. You can just make a more precise observation, just give a prompt feedback to the local administration, for example. People can just act in a matter of a few days after this observation is given. You can counteract, for example, natural disasters or something like that. This is a very prompt service that actually is not possible nowadays. For example, if you think about making monitoring through airplanes or flying objects, this is actually impossible. People think that space is expensive, but actually if you think of making different passages of, for example, with an airplane or an helicopter to observe the terrain, you have to think that hours of flying of these objects just cost something like thousands of euros, for example. And once a satellite is put in orbit, actually it almost, I would say, stays in its orbital slots with the minor corrections. So once it is in it, it is available for years. And you can sell this service to the public, for example. Just to make just to be precise with people who are listening, and we always say, okay, we give services, we give this or that, but without being more precise. I think this is a great example. And you also mentioned the mass production concept, which is a very new one, but one objection that maybe can be done from people who are outside of this world, but also from people who are in the field, could be, okay, you make mass production, but we have seen what mass production is for commercial industry, phones, cars, and everything like that. They are all inside the mass production environment. So what would happen if satellite just end up in that way? So which is the sustainability approach, and how do you see sustainability in general for satellites, for example?
And thanks also for your comment regarding the services. If I can comment shortly before going to sustainability. I think you touched the right point. It's about providing services, and we are gonna, I can't wait to show you what we'll deliver with our constellation, but we are packing a lot of technology in that. Going back to the discussion we had about, let's say, developed technology that can be commonly shared between different applications, between different programs. We brought what we learned from Argomoon, from LiCeCube about onboard processing, about autonomy in our IRIDE satellites. They are gonna pack a lot of computing power. We are talking about the computing power that you can have at your desk in your workstation. So that level of capability, we are not just talking about, let's say, standard avionics, embedded system. We are talking about proper computing capabilities, and that can open, let's say, a lot of scenarios. Not only the usual one, which we are going to cover, so shooting picture, downloading that to ground, serving the government, the agencies, and so on. But we can do, and we will do more than that. We can, let's say, bridge the gap with the more commercial user-centric services. We can deploy more complex applications. We can extrapolate data directly on the satellite from the images we shot. So I think that we are going towards a revolution of what the satellites are used for and what is doable for satellite, which is already it is already meaningful. It already has sense today, as you were saying, but it will benefit a lot from the introduction of new technologies in the future. And talking about future and sustainability, for us, it has always been paramount to work at a sustainable solution from the start. Our first satellite mission were Argomoon, were LiCeCube. They were, let's say, launched towards very sensitive environments. We are talking about the moon, we are talking about asteroids. And so they were developed from the start, thinking at the end of life in mind. So which will be the final trajectory of the satellite? What are going to be about the batteries? Are they going to explode after 10 years or not? Are we going to generate debris? How are we going to passivate the satellite at the end of life? So given the fact that we started from the scientific world, the scientific mission, working together with the Italian Space Agency, with NASA, it was extremely important for us to include from, let's say, the product requirements included sustainability, included be respectful of the environment we were going to explore. And now this is something that we brought also in the IRIDE satellite, and we are implementing in all the mission and product we are working on. We are working, for example, on another lunar mission, which is called the Lumio. We are working on space weather missions, both in Earth orbit and beyond. And so, actually, we also developed, for example, a specific product for the European Space Agency, which is about battery management and at end of life. So it's about disconnecting properly the battery from your satellite, depleting the battery in order to guarantee that it will not explode like some smartphones a few years ago. It's something that it's not trivial, because if you think, usually you design the satellite to not be disconnected from your power source. You design the satellite to not be starved from power. You disable the you let's say design the satellite to be robust and resilient with respect to everything that can happen. So designing something that for 5 years do everything it can in order to work reliably, and then with the same reliability as to completely disable itself for the next 25 years, guaranteeing that no matter what you do, it will not turn on again. It's, let's say, not trivial, but it was, for example, one of the projects that we developed for the European Space Agency together with a partner in UK. And again, this is about what I was saying regarding the collaboration between something that you can do with an agency for a scientific mission, but something then that you can also use for commercial services. And this is also, let's say, the European Space Agency, the Italian Space Agency are working in this direction as well, and we are doing our best to leverage as much as possible these kind of opportunities.
Yeah, actually, while you were mentioning the fact that you at the beginning start to build the satellite as much as robust as possible, and then you try to, let's say, distract it in the best way possible. I'm visualizing people who are giving their best to build the best satellite, and then a different team who tries to destroy it. So yeah, it must be funny. And yeah, I would like to use this introduction just to make another question, who maybe is interesting for a lot of people who are listening, who are living in the area or are dreaming to work for a space company. So you mentioned also in the beginning of this interview that in the very first months of the company you were something like 20 people, and now you will be 160, so times 8 your initial workforce. So how does the talent acquisition works in the company? So which are the characteristics of a person you look for when hiring, basically?
If I had to answer with one word, it would be passion, probably. But our colleagues are our most important resources, and I mean that. I know it's something that you listen probably from out the company you talk to, probably, but especially let's say when you are a few, each of the few counts a lot. If you are in a small team and in addition you try to do very difficult things, it counts a lot twice. So let's say we were really we pay great attention to the people that we took in. We pay great attention to the culture and the work ethic that we have in Argotec, because especially when you work at challenging environment with really tight schedule, when you ask for excellence to the people that you have, the only way to be successful at that is to have a very strong work ethic, to have a good culture, to have a place where everyone can find, let's say, a chance to follow his or her ambition. And this is, let's say, one of our, let's say, of the motto that you will find in Argotec is space for ambition. We really try to give everyone the opportunity to follow his or her path. And we have paths for many different kind of young professionals. For example, in my team, in the electronics unit, we have great technicians that we almost took straight from school or from the ETS, which is a kind of technical school that I think works very well. We have engineers in many fields, from telecommunication, software, hardware, machine learning expert, and we also have quite a lot now of PhDs. So people that went beyond the master's degree, that spend other 2, 3, 4 years, let's say, going deeper and deeper and going vertical in the arguments that they chose. And then we have a lot of people also which is not in engineering, because we do a lot of other things, you know. So it's I think that Argotec is really it's not an easy place in the sense that I was talking about performance, excellence, challenging environment. So it's not something which is probably let's say the right place for everyone. But if you are ambitious, if you want to excel, if you want your chance to contribute, to really contribute to the industry, to bring it to the next level, I think Argotec is a place where you can find your chance to do that. And that's the reason why we have extremely good people working here for us that help us delivering the products and the services that we are delivering.
Yeah, and I think that everyone can see the great results you're having in these years. Yeah, that's amazing. So for all the people that are still motivated and are amazed from what you do, and also thanks for precising that you are not only hiring engineers or highly technical people, which actually I see that you cover a wide spectrum also on the technical level. You mentioned the ETS, which is a sort of technical school in Italy, but it's something like you do after your high school. You make some few years of let's say specialization, and then okay, you have engineers, PhDs, you have very technical people, and also people who are not technically but work on different fields. I think that that was a great answer. As you said, okay, every time I hear you need patient work here, you need patient, you need your commitment and everything. Okay, this is the first step, but then you need technical skills, or you have to be good at what you do. And yeah, the results are great. So congrats. And for people who are amazing like me, basically, which are the future projects that you have you are working now, and maybe the project that will come later. So let us dream.
So I would start from the scientific missions that are a huge let's say push, a huge motivation for a lot of us. So we are continue building on the legacy of Argomoon, of LiCeCube, with the help and the trust of the European Space Agency, the Italian Space Agency, NASA. So, for example, we are now working on two 12-unit CubeSat that will be for deep space exploration. So Argomoon and LiCeCube were 6U platform. Now we are working at platform with even bigger capabilities, so twice the size. One of these two missions, which are really, let's say, the flagship CubeSat mission for space exploration of the European Space Agency and of the Italian Space Agency, one of the two is Lumio. It will be a CubeSat that will be launched on the far side of the moon, and it will monitor the impact between meteorites and the far side of the moon, something that you cannot do from Earth. And it will be very challenging because apart from operating in deep space, you also need a ton of onboard processing in order to compute in real times and to process, let's say, the flashes that you have when a meteorite impacts the moon, which are very, very fast flash. But you can imagine that you have to do that because otherwise you will record a lot of data of, let's say, nothing happening. And then probably once every, 3 days, you have a 10 millisecond flash, and you don't want to fill up your memories and take the ground station time to download all the unneeded data. So again, we are going to reuse our onboard processing technology, the capability that we developed to enable a mission like Lumio. And another mission probably still, let's say, with a higher difficulty level, it's Henon. Henon, it's a space weather monitor. So basically, it will monitor with 3 different instruments the sun activity. So we are talking about solar storms in particular. And the point of solar storms is that they can be disruptive for services on Earth. So you want to know about the storm in advance. What Henon will do, it will cover the distance, a tenth of the distance between Earth and the Sun in order to be closer to the Sun with respect to Earth. And being closer to the Sun, it will have the time to, let's say, have a look at solar storm happening in advance with respect to Earth, sending alarms to ground. And that will give time to us, for example, to secure the state of important assets like GPS satellites, the electric network on ground, so on and so forth. We are talking about extremely challenging mission. For example, Henon will take a few months, and let's say in total it will be a multi-year mission in order to reach its final destination. So we are talking really about beyond state of the art, and that's, let's say, just a glance at a few missions we are working on. Of course, we are working, as I said a little bit earlier, we are developing disruptive services based on Earth observation satellites, but we are also working at other services. For example, we are working on an amazing product together with NASA JPL in order to enable future services around the Moon, around Mars, and to support in general next generation telecommunication in the whole solar system. So we are talking again about very high speed, something that you can expect to have on Earth, so hundreds of megabits per second, but from the moon, and we are talking about being able to support customers for, again, telecommunication, but also positioning. So let's say GPS-like capabilities, not only here on Earth, but also in deep space. Also on the moon, that probably will be the first frontier, the first new frontier to be crowded in the next years. But then also, there are a number of companies, for example, looking at asteroid mining, or there are, of course, other players like SpaceX going heavily on the colonization of Mars. So we are going to be ready for these new environments, and we will be more than ready. We will be the enabler for part of these new ecosystems.
Yeah, so I think that an amazing future is awaiting for us, and yeah, I see your fingers crossed. And yeah, so for the people who'd like to know more about Argotec, we'll release more content also on the SpaceInfo Club platform. But if you want to be fast and give a look now, you can visit their website at argotecgroup.com, and you can see everything they do. Also visit their Instagram account and also the media press, so you can have further details and have a close look to what Argotec is doing. Now, for the moment, I deeply thank Emilio for being here with us, and for all the information and the insights that give us. So thank you, Emilio.
My pleasure, really. Thank you for the opportunity to tell a little bit about our job and what we do. Really, I appreciate that.
Hope to have you again soon on the SpaceInfo platform. Thanks for listening, and see you in the next episode.